Hey, sixth grade, welcome to part two of lesson one of chapter two, which is all about mineral formation. So last week we were talking about some characteristics of minerals, and one of those characteristics was that they have a crystal structure. So for the next few minutes, we're going to talk about how those crystals form and what conditions on the planet allow for the formation of mineral crystals. So there are basically three ways in which minerals can crystallize. They crystallize through hot water solutions. They crystallize from evaporation of water, and they crystallize from the cooling of magma. And so our lecture today is going to be all about some of a bit more specifics about these three ways that minerals form. So we said they form from these inorganic processes. These are the three ways: hot water solutions, evaporation of water, and crystallizing from the cooling of magma and lava. And each one of these scenarios produces different types of minerals, different sizes, and different chemical compositions. So let's get started with minerals forming from evaporation. So I think we first have to just review what a solution is. So when one substance is dissolved into another, we call that a solution. So elements and compounds can be dissolved in water, and when the water evaporates, what gets left behind are the minerals, or the elements and compounds, because they do not evaporate. So water can evaporate just based on heat from the sun, but you're not going to find minerals evaporating, so they get left back when the water evaporates. So a lot of these types of minerals are salts. So halite is a great example. Gypsum and calcite are also other examples of this. We find a lot of these gypsum type mines out in the American Southwest. I actually have a great example of a gypsum rose in the class that we'll take a look at tomorrow. And if we have kind of a salty solution or a salty lake and it evaporates, what gets left behind can be some halite. And so we'll show you some of that as well. So minerals forming from evaporation is just a solution in which the water evaporates, leaving the minerals behind. So our next one is minerals forming from hot water solutions. Now, this is a little bit different because our minerals forming from evaporation, they're ones that are not like deep. We don't find those in deep mines. Those are more our surface minerals that can be mined from surface mines. When we're talking about magma heating a solution, we're talking about minerals that are found deep in the Earth's crust, because we're saying a magma source is heating the water. And so we've already talked about the hydrosphere and that water exists not just on the surface, but also beneath the surface. And so elements that are dissolved in hot water leave this. So let me just say, the magma is so hot that it causes some of these elements and compounds that make up minerals to be dissolved in the water. Okay. And then when the magma cools, it leaves, the minerals leave the solution. Now this forms very specific types of minerals, and one thing you'll see here, they can form veins. So number one, the minerals are found deep in the Earth's crust. And number two, because we're talking about the minerals leaving the solution as the magma cools, they can form things that are called veins. And let's take a look at silver and gold are great examples of minerals that are found in these veins. So like areas of either they look almost like rivers, but they're either thin veins or big slabs that are different than the surrounding rock. It's as though they intrude the rock. They move away from the magma source and cool and leave the solution and then form these veins. So gold mines, silver mines, they're not going to be surface mines. Although you can find gold on the surface, and we'll talk about how that occurs, these are generally deep surface or deep mines that must be extracted from deep mines. Another example of a mineral forming in a hot water solution is selenite. This is mined in Mexico, and this, actually I should say a cave in Mexico, where these enormous selenite capsules were found. I love this picture because it gives a great scale of how enormous these crystals are. When you see the explorers here, the cave explorers in the background. Okay, so again, when we're talking about minerals that form from hot water solutions, we're talking about magma heating the water. We're talking about minerals that form from evaporation. We're talking about the sun's energy evaporating the water and leaving minerals behind. Minerals from hot water solution are deep underground where magma heats them at a very high temperature, and the hot water dissolves the compounds that form the minerals. And when the magma cools, the minerals leave the solution in this form of veins. And examples of this are quartz and gold. Finally, we can have minerals that form from lava and magma. Now, lava is magma that has come to the surface and broken through Earth's surface. These form different types of minerals because they have much different cooling rates. Okay, so when magma and lava cool, they form crystals. And so the elements and compounds that make up crystals, they exist, or make up minerals, they exist in the magma. And so when this magma cools, these crystals form. The rate at which the magma cools and the gases it contains affects the minerals that form. That's why the minerals from magma and the minerals from lava can be quite different. Magma cools more slowly because it's cooling deeper in the Earth's crust, and it tends to cool when it moves away from kind of its original source, and that takes time. And so when we're looking at magma, we're looking at crystals that are, we call them coarse grained, where a rock that has hardened, that is magma, is a coarse grained rock because its crystals are larger and easier to be seen. They have time to form because the magma cools more slowly, as opposed to lava. Lava has small crystals because when it comes to the surface, it is further away from its source of heat and it cools more quickly. So it does not give a lot of time for minerals to form. So magma takes longer to cool. So crystals that make up minerals have longer to form, whereas lava cools more quickly. So minerals don't have a long time to form, and so you find smaller crystals. Okay, and some of these from, so I think I grabbed a picture. Yeah, there we go. So here's a picture of granite, which is an igneous rock that is, we call it intrusive igneous rock, and don't worry, we'll get to that. But it's found deeper in the Earth's crust, and so its minerals form when magma cools. And you can see just from this image, and I know you're familiar with granite, you can see from this image that the minerals feldspar and quartz are very easy to see. They are large. Granite, again, is an intrusive igneous rock, meaning that it forms from magma that has cooled deep in the Earth's surface. And if that's the case, then these minerals have longer to form, and then they are larger. You only need to look at a piece of pumice, which is an extrusive igneous rock, which means it's formed from lava. Lava's come to the surface and it cools quickly. It's not that minerals don't exist in pumice or other extrusive igneous rocks, it's that they're difficult to see. They are so small because they have not had a long time to form. The cooling rate of lava is much faster, and so minerals don't have time to form. So this week we're going to be looking at some samples of different types of minerals and talking about how it relates to their formation. So thank you. Have a good night. Go Ducks.